Well, first, I am recording this, just so you guys know, I am recording this because some people are not here. Not many, just Sierra and Sammy, but maybe Sierra would like to look at it for our review. And it's gonna be quite quick today. So let me just figure out how to make this a new sheet. Clear my drawings. Okay. So I'm just going to work on the whiteboard on Zoom and you guys just work on a piece of paper. So let's do this. I'm going to have a place where you are going to upload your review notes for today. Okay. So for today, you're not going to have an assignment today, tomorrow, or Thursday, but your assignment, kind of like the notes previously, is to just from yesterday's upload pages of your notes. Okay. So a completion grade, either you do it or you don't. Okay. Either you upload it or you don't. I got to make a note for myself. Upload math notes. Okay. That way I can go in and make an assignment when I get done with this for you guys to upload it. So all you have to do today is write down scientific notation review. Okay. Scientific notation review. And everything that we write down, you guys just write down, whether it be on Cami or on a piece of paper. Some of you like to be very, try to be sneaky and you take a screenshot of my work and upload my work to my I appreciate your usefulness of your brain, but I would like for you to upload your work, not my own work. Okay. I actually want you writing it, doing as we do this. Um, if you want to take the notes in your book of math, that is fine. Just to have that housed in a place, but I'm just writing this on the screen, so I'm not going to have it in my book of math, so it won't be a part of your book of math check. Um, but that would be a good idea to take it in your book of math so you have those to review in that one single place. Okay. All right, so we are reviewing scientific notation. You are taking the math benchmark on Friday. Okay. Just for some numbers sake, eighth grade math, we only have 10% of students being proficient, meaning 10% of students are testing on grade level. Okay. That's really low. Yes, the situation this year is weird. And normally I don't worry about benchmark, but the school is really focused on our benchmark scores this year, which doesn't make sense. Again, being a weird year. But you guys, it reflects your knowledge, but it also reflects my teaching. So if you guys can please just make sure you try really hard, stay awake, don't guess. I mean, guess if you have to, but if you can, just put effort into it, please, to just show that we are learning stuff. I promise we are learning stuff. So just care about that assessment a little bit more this time if you haven't in the past. Really appreciate it. Okay. And your grade would appreciate it. Okay. So scientific notation. So first, let's just start with the conversions. So I want you to convert um, 3.2. That's a decimal. I need to probably make this a little thicker. 3.2 times 10 to the fifth. Okay, so convert 3.2 times 10 to the fifth into standard form. Convert it into standard form. It is in scientific notation. Convert it into standard form. And Rebecca, Madison, and Jocelyn, thank you so much for having your computer screens on. So I'm not teaching to screens of names or faces. It's much nicer teaching to actual live people. So thank you very much. That stuff I keep up here. And like if you're borderline, like A or B or borderline B or C, I'm like, oh, they were so kind on Zoom. I'm going to bump them up. Those are things teachers remember. Okay. So thank you. Okay. All right. So we're going to convert this. If it is a positive exponent, you move the decimal to the right that number of places. Okay. So if I have 3.2, I'm going to go 1, 2, 3, 4, 5, and fill these up with zeros. Now I should expect there to be 4 zeros because one of the 5 jumps was the 2. So the number is 3, 2, and then 4 zeros, 1, 2, 3, 4. Okay. I gave you a second to try to do it, or a minute to try to do it on your own first. And And then go back in, once you move that and you've blown up that number to times to the fifth, it became a much larger number than 3.2. Go back through and add those zeros for every third number. So I've got 1, 0, 2, 0, 3, 0, put a comma. Okay. Every single time you have a third place value, put your comma. Okay. And that would be converted into standard form or decimal form. Okay. 320,000. Okay. Positive exponents like this 10 to the fifth, that number is going to become larger. If it was a -5, it's going to become smaller. Okay. Or a decimal. All right. So hopefully you are taking notes along with us. Okay. All right. And let me figure out. There we go. All right. New screen. I was confused there. All right. Now I want you to convert 5.31 times 10 to the -4th. Okay, now I want you to convert this one. This is in scientific notation. Okay, now I want you to convert it to standard form. All right. If it is a negative exponent, you move the decimal 4 places to the left. Okay, this number is going to become smaller than 5.31. It's going to become smaller. So I'm going to take 5.31. I'm going to move the decimal places to the left. 1, 2, 3, 4. There's my new decimal place, not there anymore. Okay, fill these with zeros. So I need 3 zeros because 4 jumps. The 1 was around the 5. So it's 0.1, 2, 3, and then 5, 3, 1. 3 zeros, and then 5, 3, 1. Okay. Now looking at that number, 0.00531, that is a very small number. Okay. It's a very small number because we got a negative exponent. Okay. So just remember, if it's a positive exponent, we're moving that decimal to the right, it's a big number. If it's a negative exponent, we move the decimal to the left, it's associated with a smaller number. Okay. Whoops. This, I don't think, was like the super complicated part of scientific notation. This was from chapter 2.1 or section 2.1. When it got complicated is when we moved into quarter 2, or we started quarter 2, and we started off with adding numbers in scientific notation, subtracting numbers in scientific notation, multiplying and dividing. When we started actually calculating with numbers in scientific notation, that's when it got a little complicated, more complicated. Okay. So now let's talk about calculating with numbers in scientific notation. Okay. What if I gave you 2 times 10 to the third, actually, no, let's take that back. 2 times 10 to the 8th, and I'm going to put a parentheses right next to it, so that means they're being multiplied. Let's do 3 times 10 to the 4th. There we go. Okay. So I have 2 numbers in scientific notation, and I know they are being multiplied together because the parentheses are touching. Okay, parentheses are right next to each other. There's not a plus or minus sign in between there. So these are multiplying numbers in scientific notation. Okay. This goes way back. This is why we're reviewing, because it's easy to forget these things, but with a slight review, hey, Miss Cinnamon, with a slight review, you guys remember them, hopefully, or be able to make better educated knowledge answers, better educated answers based on this review. Okay. All right. Does anyone remember what we do with the 2 and the 3 with the coefficients? Okay, you almost there. There is an adding portion, but that was with the exponents.
Multiply.
Yes, there we go. Good job. Okay. So yeah, like I said, and see that's where it's like, like I would hate for Jocelyn, I would hate for you to miss that, because I know you remember, you like when we did this, you were killing it, but it was so long ago, right? So when you're multiplying, you multiply the coefficients and you add the exponents. Okay, so 2 times 3 is 6. Sometimes I say 5 on accident. My brain is weird like that sometimes. So 6 times 10 to the 12th. And that would be our answer. Okay, so when we're multiplying, we multiply coefficients and we add exponents. Excellent. Okay. We are going to do another one of these. We're going to do just a couple more where we're calculating with scientific notation. Okay, so let's look at another multiplying one. Okay, let me do 6 times 10 to the 7th times 6 times 10 to the 8th. Whoop, whoop. I'm trying to make that an 8. There we go. All right, made it an 8. Okay, so we got to multiply the coefficients and we add the exponents. So when you multiply the coefficients, though, 6 times 6, that's 36, times 10, add the exponents, we get 15, okay? Now, I'm not going to box that answer in, though, because that number, it looks like it's in scientific notation, but it's not exact scientific notation. This is where we had to take another extra step sometimes with our answer at the end and convert it into exact scientific notation. The number 36 is supposed to be between 1 and 10. You're all like, oh, yeah, that's right. I remember that. 36 is supposed to be between 1 and 10. So right now, that 36 has a decimal right behind it. So I need to bump it over just once to become 3.6 times 10. Remember, if we did the one jump at the decimal, we had to add the one jump to that exponent. Okay. So now it is 3.6 times 10 to the 16th. Now that answer is an exact scientific notation. Okay. All right, now that we've done some multiplying, now I'm going to give you a problem of division. Okay, so use your knowledge here, even though it's been a long time since we multiplied and divided. Now that I've kind of reminded you how to multiply, see if you can turn it in and use what you know to do division. So let's do 8 times 10 to the 12th divided by 4 times 10 to the 7th. Okay. I'm going to give you a moment. See if you can get that. I feel a little bit better about this one now that we talked about multiplication. Okay. Does anyone remember how we put the 8 and the 4 together?
Divide.
Yes, we divide the coefficients. And what do we do with the exponents now?
Subtract.
Perfect. Subtract them. Okay, just opposite of the multiplication, right? So 8 divided by 4 is 2. 12 minus 7 is 5. So now it's 2 times 10 to the 5th. Good job. Just a reminder, you will be uploading these photos. So I see those of you that I can see. Wonderful ladies. Oh, and Jacob. I see Jacob. Make sure that you guys are the ones who I cannot see. I hope you're there because you are going to be uploading these for me to check. Just kind of make sure you're paying attention. All right, next up, let's do another one. I make this one a little bit harder. 3.2 times 10 to the 9th divided by 8 times 10 to the 4th. Okay. And I am recording this, so I'm going to go post it on Canvas Daily Directions. So if you missed something or didn't get written down and you need to put those notes up, you can just go rewatch it. Okay, so now we just talked about this. We divide the coefficients and we subtract the exponents. So some of y'all, and this, you know for sure, or I can tell you that scientific notation is more than likely going to be on the non-calculator portion because they want to see your skill on calculating with these numbers in scientific notation, not with a calculator. So back when in quarter 2, we learned that we didn't have to do 3.2 divided by 8, that you could bump that decimal back and think of 32 divided by 8. And what is 32 divided by 8?
4.
4. So you can make that 4. But then you got to make sure where you bump that decimal over in the beginning, you got to bump that decimal back. Okay, so really so 3.2 divided by 8 is actually 0.4. Okay, times 10, and then you just subtract these exponents and you get 5. Okay, so 0.4 times 10 to the 5th. But that number is not an exact scientific notation. And now this is the opposite because it was a small number. So I'm bumping it back, which means I need to subtract it 1. Okay. So my answer in scientific notation specifically is 4 times 10 to the 4th. Okay. Since that we're subtracting the 1 jump because that 0.4 was less than 1. So we got to take that 1 away. If it was greater than 1, we'd add those jumps to it. Okay. Okay. And we're going to do one more. We're going to do one more problem because multiplying and dividing were actually easier than adding and subtracting. Because multiplying and dividing, we could divide whatever, multiply whatever, subtract, add the exponents. We didn't really have to change any of that stuff until maybe the very end. We had to change it to make it an exact scientific notation. But adding and subtracting were not that easy. Okay, so let's look at a subtraction one. Let's do 8.5 times 10 to the 7th minus 9 times 10 to the 6th. Okay. Now this is, the subtraction also applies to addition. And the difference between here, so if it's subtracting, you can't just do 8.5 minus 9. You can't just say 8.5 minus 9 because they have to have the same exponents. One is a 7 and one is a 6. Okay, that's like apples and oranges. Okay, you can't subtract or you can't combine apples and oranges. You got to have apples and apples or oranges and oranges. Okay, now multiplying and dividing, that was a little bit better because it didn't matter. Okay, but adding and subtracting, they have to have those like base 10 exponents. Does anyone remember which one I told you to choose? The smaller one or the larger one?
Smaller one.
I did, yes, Jocelyn. I told you to choose the smaller exponent. So the 9 times 10 to the 6th, that one's good. We don't have to change that one. Okay. We're not going to change that one. We want both the exponents to become or be 10 to the 6th so that we can subtract the coefficients. Okay, which means I need to convert the 7 to be 10 to the 6th. So now I want that to become 10 to the 6th. So then I can subtract the coefficients. What's the difference in jumps between 7 and 6? Just one jump. So I need to start converting 8.5 times 10 to the 7th. Start converting it by moving that decimal to the right 7 places, but I only need to move it 1 jump. So now it's 10 to the 6th. So 8.5, I'm just going to do 1 jump. So now my coefficient is 85 times 10 to the 6th. Okay. Now, since they have those same base 10 exponents, now I can do 85 minus 9. Which I'm going to have to borrow some stuff here. Borrow, make that a 7, make that a 15. 15 minus 9 is 6. So 76. Oh, I could have also done 85 minus 10 was 75. So 1 short is 76. All sorts of that mental math stuff. All right. So my new coefficient is 76. And then it's times 10 to the 6. So this is where you had some 10 to the 6. You took some 10 to the 6 away. Now we got another number times 10 to the 6. Okay. Oh, but it's not in exact scientific notation. Bump that decimal over. Make it 7.6, a number between 1 and 10, times 10 to the 7th, because you have to add that exponent. Add 1 to the exponent. Add that jump over. And since 76 was greater than 1, you add the 1 jump to the exponent. Okay. All right. So those problems that we did, you are going to upload into Canvas. And let me get into Canvas right now and make an assignment. Math at home. Assignments. Scientific notation review notes. Upload your review notes on scientific notation from the Zoom on Tuesday, 3/23. Okay. We'll make that due by 10 o'clock tonight in case, someone just needs to go back and rewatch it. And I'm going to save and publish that. Okay, so it is now viewable in Canvas for you to go upload your notes.